Welcome, everyone, to Saltwater Stories. We're here exploring the most amazing journeys across our oceans.
That's right. And today, we're looking at a creature that basically decided winter just wasn't for it.
Huh. Yeah, a true global traveler that chases the sun, moving constantly to avoid the cold altogether. An endless summer kind of life.
It sounds relaxing, but the journey involved is anything but.
Yeah.
We're talking about maybe the most impressive traveler on the planet. Tiny, elegant.
Okay, don't give it away just yet. We've got some really fascinating research here, and our goal today is to really understand this champion endurance flyer.
Right.
And to kick things off, I want you to picture this. A single, really small bird.
And when we say small, we mean it. Imagine something that weighs about the same as a tennis ball, maybe 90 to 120 grams.
Right.
Really light.
Featherlight, literally, but incredibly tough. So scientists tracked one of these birds, and get this, it lived for 34 years. That's the record.
Which is already pretty impressive for a small bird flying over open ocean half its life.
But here's the mind-blowing part. Over those 34 years, flying back and forth, pole to pole, every single year, this one bird flew a total of 2.4 million kilometers.
Wow. Okay, let's try and wrap our heads around that number, 2.4 million kilometers.
It's hard, isn't it?
Yeah. That's like flying from here, Earth, to the moon, and back again, more than 3 times.
Exactly. 3 round trips to the moon, powered by what? Tiny wings and instinct. It's just staggering.
It really, really is.
So this incredible creature, this champion of perpetual summer, is the Arctic tern, scientific name, Sterna paradisea.
The paradise tern. Quite fitting, actually.
It really is. So today, we need to figure out how. How does this tiny bird pull off this unbelievable pole-to-pole odyssey?
What's going on inside its body? What special tools does it have? From its bones to its cells.
And what does this incredible journey tell us about, well, the health of the whole planet, since its life connects the absolute extreme of the Earth?
That's the plan.
Yeah.
It's a huge story packed into a tiny bird.
Okay, so let's start with the bird itself, the ultimate flying machine. It's about 35 centimeters long, so not big.
No, quite medium-sized for a seabird, actually. But it's the shape that's key. Very slender, very streamlined. You watch them fly, they're just pure grace.
And they have that nickname, right, the sea swallow.
Yeah, exactly. It comes from that tail. It's deeply forked, with those really long outer feathers sticking out behind it. Streamers, they're called. It really does look like a swallow darting around over the water.
But the real secret sauce for traveling the globe has to be the wings, doesn't it?
Oh, absolutely. The wings are, well, they're masterpieces. They're long, quite narrow, and they come to a sharp point.
Engineers call that shape a high aspect ratio, I read. What does that actually mean for the bird when it's flying? Like for us non-engineers?
Okay, think about it like this. Compare a stubby fighter jet wing to the wing of a super efficient glider, right? The glider's wings are really long and skinny.
Right, okay.
The tern's wings are like the glider's. That long, thin shape is really clean aerodynamically. It cuts through the air with minimum fuss. Specifically, it reduces something called induced drag.
Induced drag? That's like wasted energy.
Pretty much, yeah. It's the drag you get just from creating lift. By minimizing that, the tern's wings turn more of the bird's energy into staying up and moving forward.
So less flapping, more gliding, more efficient travel over long distances.
Exactly. Super efficient, sustained flight, lots of gliding. Absolutely essential when you're crossing thousands of kilometers of ocean with nowhere to stop and rest.
Okay, so the shape is perfect, but the efficiency story goes deeper, right down to the bones. Now, we usually think bird bones are hollow and light.
Correct. Pneumatic bones. That's the standard idea.
But the research says the Arctic tern's bones, while hollow, are actually denser than a land mammal's bones of the same size. That seems wrong. How can that be good for flying?
It does seem counterintuitive, doesn't it? But it's about smart design, like material science genius by nature. Yes, the bones are hollow tubes, but they aren't empty.
Okay.
Inside, they're filled with this intricate network of tiny struts and cross braces, like microscopic scaffolding.
Ah, okay. So it's like the internal structure you see in, say, carbon fiber parts for racing bikes or airplanes, makes it strong but keeps it light overall.
Precisely. Think of high-tech composite materials. The density comes from using stronger material arranged in this incredibly clever weight-saving structure. It gives them maximum strength for minimum weight.
So the skeleton itself is built for endurance. It can handle the stress of constant flight year after year.
Exactly. A super light, super stiff airframe that won't fail mid-journey.
Okay, so you've got the airframe. What about the engine, the muscles powering those amazing wings?
Right, the engine room. It's mainly about the big breast muscles. Everyone knows the main one, the pectoralis, that does the powerful downstroke. That's the big muscle.
Yeah.
But the really clever bit is how they pull the wing back up for the recovery stroke.
Okay, how does that work?
There's a smaller muscle, the supracoracoideus. Now, you'd think the up muscle would be on top, but it's not. It sits underneath the big downstroke muscle.
Underneath. So how does it pull the wing up from below? Seems like it's pulling the wrong way.
Ah, this is the genius part. Its tendon loops up through a special little hole in the shoulder bone. It's called the foramen triaceum and attaches to the top of the wing. It works just like a pulley.
Wow, okay, a biological pulley system.
Exactly.
Yeah.
And by keeping both major flight muscles tucked underneath, close to the bird's center of gravity, it makes the bird much more stable and balanced in flight, which again saves energy over those long hauls.
That's incredibly clever engineering. And I bet those muscles aren't just regular muscles either.
Oh, definitely not. They are biochemical powerhouses built purely for endurance, not for short bursts of speed.
What makes them so special?
If you look at them under a microscope, they'd be absolutely packed, just crammed with mitochondria.
Mitochondria. Those are the tiny energy factors in our cells, right?
The very same.
Yeah.
And they're also flooded with tiny blood vessels, capillaries, bringing in a constant, huge supply of oxygen. It's like having a super efficient engine that can run at high output aerobically for days and days without stopping.
Okay, but running any engine that hard for that long, doesn't that cause damage? Like internal wear and tear. I think the term is oxidative stress.
Exactly right. It's a major problem. All that high energy activity creates damaging molecules, free radicals, like internal rust building up in the system.
Yeah.
It's the cost of doing business at that metabolic rate.
So how does the tern cope? It can't just rust out halfway across the Atlantic.
It has an incredibly advanced system to deal with it. The research calls it superior oxidative integration. Think of it less as just cleaning up the rust and more like having a full-time, highly skilled maintenance crew working inside the cells 24/7.
A maintenance crew. How does that work, simply put?
Well, imagine those mitochondria, the power plants, are creating exhaust fumes. That's the oxidative stress. The tern has evolved special enzymes and antioxidants, like little mechanics, that immediately neutralize those fumes, repair any tiny bits of damage to the cell structures, and basically keep the whole system running smoothly, even under extreme load.
So their endurance isn't just physical strength, it's also about having this amazing internal repair system working constantly.
Precisely. It's biochemical endurance at its finest. They minimize the damage as it happens.
Okay, you can't run a super engine, even with a great repair crew, without top quality fuel. And for the tern, that fuel is fat.
Fat is absolutely the fuel of choice. It packs the most energy per gram, much more than carbohydrates or protein, essential for long-distance travel.
And before they set off on these huge migrations, they go into a special feeding mode, right?
Oh yes, it's called hyperphagia, basically hyper-eating. They develop this intense, ravenous appetite and just gorge themselves.
How much weight do they actually put on?
It's astonishing. They can store fat reserves that equal 40% to even 100% of their normal lean body weight.
Wait, 100%? They double their weight?
Pretty much. They transform themselves into, well, flying fuel tanks,
Yeah.
just packing away energy for the journey ahead, especially for crossing areas like the tropics where food might be harder to find.
That's incredible. A flying fuel tank. I like that. And they're smart about energy saving when they're not flying too, right? Like during nesting?
Absolutely.
Mm-hmm.
Total masters of energy budgeting. During the less demanding time, like when they're just sitting on the nest incubating eggs, they cut back on unnecessary costs.
Wow.
One amazing example is the gizzard. That's the muscular part of the stomach that grinds up food. Research shows that during incubation, their gizzard can actually shrink atrophy by nearly 40%.
Wow. So they basically digest part of their own digestive system to save energy.
In a way, yes.
Yeah.
Why spend energy maintaining a big, powerful food processor when you're not eating that much or working that hard? Every little bit of energy saved counts.
And then they rebuild it quickly before they need to start eating heavily again for the migration.
Exactly. They shrink it down when they don't need it, save the energy, and then bulk it back up right before the big feeding frenzy starts again. It's incredibly efficient optimization for every stage of their annual cycle.
Okay, tanks full, engines tuned, repair crews ready. Time for the big trip. We mentioned the crazy lifetime mileage, but what about a single year? What's the typical round trip?
The average annual round trip is already staggering, about 70,900 kilometers. That's, what, over 44,000 miles?
Yeah, roughly.
And that's just the average. Some populations, like those breeding in the Netherlands, have been tracked flying up to 96,000 kilometers in a single year.
96,000 kilometers,
Uh,
nearly 60,000 miles in 1 year, every year.
Mind-boggling, isn't it?
Yeah.
But what's also really interesting is the difference in speed between the journey south and the journey north.
Oh, yeah. How so?
The trip south from the Arctic breeding grounds down to the Antarctic is actually relatively slow. It takes them about 93 days on average.
Okay, 93 days. That works out to about 330 kilometers or maybe 200 miles a day. That doesn't sound that fast for a bird.
It's not racing speed, no. It's what scientists call a fly-in forage strategy. They're not in a huge rush going south. They take their time, stop frequently to hunt along the way, refuel as they go, kind of meandering southwards.
Ah, okay. But the return trip north is a different story.
Completely different. Spring is coming in the Arctic. The biological clock is ticking. They need to get back to claim the best nesting spots. The pressure is on.
So they put the pedal down.
Big time. The northbound journey takes only about 40 days. They're covering more like 520 kilometers over 320 miles every single day. It's a much more direct, urgent flight.
Wow, almost double the daily distance. And the road itself isn't just a straight line on the map, is it? I read about this amazing S-shaped path they take up the Atlantic.
That's right. They are absolute masters of using the wind. They don't fight the weather, they ride it. That S-shape isn't the shortest path, but it's the smartest path.
How does the S-shape help?
It's all about harnessing the power of the major wind systems, the atmospheric gyres. Think of them like giant rotating wind patterns in the ocean basins. On the way north through the Atlantic, they fly in a way that keeps the wind at their backs as much as possible.
So they kind of fly counterclockwise around the wind system in the South Atlantic and then switch to clockwise around the one in the North Atlantic.
Exactly. By following the edges of these rotating gyres, they maximize their time flying with strong tailwinds, getting a massive push that saves energy and boosts speed. It's like a sailboat, using currents and wind to travel efficiently. Flying straight into the wind would be exhausting.
That's seriously sophisticated atmospheric navigation,
Yeah.
which brings up another puzzle. These birds are all one species, genetically, right? Monotypic, the term was.
Correct. Genetically, they're pretty much uniform across their range.
But different populations take completely different routes and end up in different spots in the Antarctic.
Yes. This is called migratory segregation, and it's fascinating. Even though they could all potentially mix, distinct populations follow specific traditional flyways.
Can you give an example?
Sure, terns that breed in Greenland or Iceland, for instance, mostly fly down the Atlantic and spend the non-breeding season, or winter, in the Weddell Sea region of Antarctica.
Okay, kind of a direct shot south, relatively speaking.
Yeah. But those birds from the Netherlands, the ones doing the super long 96,000-kilometer trip, they do something completely different.
What's their route?
They also head south, down the Atlantic, along the coast of Africa. But instead of staying in the Atlantic sector of Antarctica, they swing east around the Cape of Good Hope, cross the entire Indian Ocean, and end up wintering near Wilkes Land in East Antarctica, thousands of miles away from the Greenland birds.
Wow. So same species, but totally different migration cultures, leading them to opposite sides of the Antarctic continent.
It's incredible. It suggests these routes are somehow learned or passed down within populations. And it's probably a good strategy for the species overall. Doesn't put all their eggs in one Antarctic basket, so to speak.
And these massive journeys rely on pit stops, right? They can't fly nonstop for 40 days straight, even with tailwind.
Definitely not. The fly-in forage strategy is still partly in play, especially going south. They need reliable refueling stations, oceanic hotspots packed with food.
Where are these critical gas stations?
One hugely important one is a big staging area out in the middle of the North Atlantic, roughly between, say, 40 and 55 degrees north latitude. Terns from multiple breeding areas, Greenland, Iceland, Europe, all converge there.
Just hang out and eat.
Pretty much. They can spend up to 25 days there just feasting on fish, packing on those fat reserves before they make the big push south across the nutrient-poorer tropical waters.
Okay. And further south, any other key spots?
Yes. They rely heavily on coastal upwelling zones. These are areas where winds push surface water away from the coast, and deep, cold, nutrient-rich water rises up to replace it.
Like fertilizer for the ocean.
Exactly. It fuels huge blooms of plankton, which then feed swarms of krill and small fish. Perfect tern food. Famous examples are the Benguela current of southwestern Africa and the Humboldt current off Peru and Chile in the Pacific. These are incredibly rich feeding grounds.
Okay, flying millions of kilometers, using winds, finding tiny spots in the ocean to refuel. This requires a navigation system that's just out of this world. How on earth do they do it?
It's not just one system. It's an incredible toolkit of senses working together, a multi-sensory compass and map that's far beyond our own abilities.
What's in the toolkit? Let's start with the basics. Sun and stars.
Definitely. They use the sun as a compass during the day, but the sun moves across the sky, right?
Yeah, so just flying towards the sun wouldn't keep you going straight.
Exactly. So the tern must have a highly accurate internal clock, a biological clock that allows it to compensate for the sun's movement and maintain a constant direction. It knows what time it is and where the sun should be to hold its course.
Okay, that's already pretty smart. What about at night or on cloudy days?
At night, they switch to using a star compass. They can navigate by the patterns of the stars, particularly the rotation of stars around the celestial poles.
But what if it's completely overcast for days, especially over the ocean or near the poles where weather can be awful? Sun and stars are useless then.
Right, and that's where the truly amazing sense comes in. Magnetoreception. They can sense the Earth's magnetic field.
Okay, the magnetic sense. I've heard about this. How is it thought to work? It seems almost like science fiction.
It still feels a bit like science fiction, honestly. But the evidence is strong. And it seems they have two distinct magnetic sense systems.
Two systems. Okay, what's the first one? I read something about a quantum trick.
Yeah, that refers to the leading hypothesis for their magnetic compass. It's thought to be light-dependent and happen right in the bird's eyes.
In their eyes? How?
They have special proteins in their retina called cryptochromes. When blue light hits these cryptochromes, it triggers a quantum reaction, creating pairs of molecules called radical pairs with linked electron spins.
Okay, getting technical here.
Bear with me. The Earth's magnetic field, even though it's weak, can subtly influence how long these radical pairs last or how they decay. This change, somehow, is translated into a signal the bird's brain can interpret.
So the theory is they can actually see the magnetic field, like a sort of overlay on their vision?
That's the mind-bending idea, yes. Not like seeing big glowing lines, maybe, but perhaps as patterns of light or dark or color shifts superimposed on what they normally see. This would act as an inclination compass, telling them the angle of the magnetic field lines relative to the Earth's surface.
And that angle changes with latitude, right?
Yeah.
Steeper near the poles, flatter near the equator.
Exactly. So it gives them a reliable sense of direction, even under thick clouds.
Wow. Okay, that's the compass which way to go. But you also need a map knowing where you are along the route. You said there's a second magnetic system.
Yes, and this one might provide the map sense. It's thought to involve tiny particles of magnetite, a naturally magnetic iron mineral found in cells in the bird's upper beak. These particles are connected to the trigeminal nerve, a major sensory nerve in the head.
And how does magnetite help make the map?
This system is believed to sense the intensity or strength of the magnetic field, not just the angle.
And the field strength also changes predictably with latitude, right? Generally stronger near the poles, weaker near the equator.
Correct. So by sensing these subtle variations in magnetic intensity, the tern might be able to figure out its north-south position, its latitude. Combine the inclination compass direction with the intensity map, latitude, and you've got a pretty sophisticated natural GPS.
Sun, stars, quantum compass, magnetic map, anything else? What about smell? Can they really navigate by smell over the vast ocean?
It sounds unlikely, but the evidence is growing, especially for seabirds. The ocean isn't actually odorless. It has what scientists call an olfactory landscape.
A smell landscape. Made of what?
Different areas release different volatile chemicals. One really important one is called dimethyl sulfide, or DMS.
DMS, where does that come from?
It's released when phytoplankton, the tiny ocean plants, are eaten by things like krill and zooplankton, the tern's food.
Ah, so DMS means food is here.
Essentially, yes. It signals a productive area, a potential feeding hotspot. The idea is that terns can detect gradients of DMS in the wind, like following the scent of smoke back to a campfire. They can literally follow the plume of food smell across the seemingly featureless ocean to find their next meal or even navigate towards productive zones.
Sun, stars, magnetism, smell, that's an incredible navigational toolkit. So after using this amazing toolkit to cross half the planet, the terns finally arrive back in the Arctic. Time to breed. What's their social life like?
They're generally socially monogamous. They form strong pair bonds that can last for many years, often for life. They usually return to the same colony and often the same specific nest site year after year and reunite with the same partner. Real loyalty.
That's quite romantic. How do they court each other after potentially months apart?
There are these beautiful aerial displays called high flights, where the pair flies up high together in perfect synchrony, like an aerial ballet.
Nice.
But the really critical part of courtship is something called courtship feeding, or sometimes the fish flight.
Courtship feeding. The male brings the female snacks.
Exactly. The male catches a fish and presents it to the female, sometimes even passing it to her in midair. It looks like a gift, but it's much more than that.
What does this signify?
It's a really important demonstration. The male is proving his skill as a hunter, showing the female, look, I'm good at finding food. I can provide for you while you're busy laying eggs, and I can help feed our chicks later.
So it's like him showing off his resume, proving he'll be a good dad.
Pretty much. And it's vital nutrition for the female, too. She needs a lot of protein and calcium to form those eggs, especially after that long, taxing migration north. So the fish gifts are crucial fuel for reproduction.
Makes sense. What about the nest itself? Do they build elaborate structures?
Not at all. Arctic terns are minimalists when it comes to nesting. They usually choose a spot on open ground, like a gravel beach, a sandbar, maybe some sparse tundra vegetation.
And the nest?
Often, it's just a shallow scrape, a little depression they wiggle out in the sand or gravel. Sometimes they might add a few pebbles or bits of dried grass, but often it's completely on the land. Very basic.
Doesn't sound very cozy or safe. How do they protect the eggs?
Well, the first line of defense is camouflage. The eggs, usually they lay 1 to 3, typically 2 are perfectly colored to blend in. They're usually a sort of buff or olive color, covered in dark brown or black speckles and blotches.
So they just disappear against the gravel and shadows.
Exactly. They're incredibly hard to spot if you're not looking carefully. Great protection against predators like gulls or skuas that hunt by sight.
But camouflage isn't foolproof. What happens if a predator does find the nest, or if something bigger, like a fox or even a person, wanders into the colony?
Then you witness one of the most impressive and, frankly, terrifying defensive displays in the bird world, the mobbing attack. Arctic terns are famously fearless and aggressive when defending their nests.
Mobbing. What does that involve?
The entire colony works together. As soon as an intruder is spotted, dozens, maybe hundreds of terns rise into the air, shrieking loudly, and launch coordinated dive bombing attacks.
Dive bombing, seriously?
Oh, yeah. They dive straight down at the intruder, aiming for the highest point, usually the head, and they will often strike with their sharp bills that can draw blood.
Ouch.
And as if that's not enough, they also frequently defecate on the intruder as they swoop past, so you're getting pecked and pooped on. It's incredibly effective at driving away threats much larger than themselves.
Oh, don't mess with nesting terns. I heard other birds actually use this to their advantage.
That's right. Birds like common eiders, which are much less aggressive ducks, will often choose to nest right inside or on the edge of an Arctic tern colony. They basically get free protection from the tern's defensive umbrella. Smart move.
Very clever. Now, after all that effort, the chicks hatch. They grow up fast, right?
They do. They can fly, or fledge, in about 3 to 4 weeks. But they still depend on their parents for food for another month or two after that.
And then comes the really big challenge. Their very first migration south. A 70,000+ kilometer journey.
And this is where we hit one of the biggest mysteries in tern biology, the juvenile migration riddle.
The riddle beam.
How does that young bird, hatched just a couple of months earlier on some Arctic beach, know which incredibly specific, long, and complex migration road to follow? Remember those different routes we talked about?
Yeah, like the Netherlands birds going via the Indian Ocean and the Greenland birds staying in the Atlantic. How does a chick know which path its parents or its population takes? It's never been there before.
It's exactly. Is that incredibly detailed map somehow hardwired into its genes? That seems unlikely given the complexity and the population differences.
So maybe they learn it from their parents on that first trip.
That's the more likely hypothesis, that the parents guide them and the young birds somehow imprint on that route for life. It becomes their traditional or cultural flyway. But how they learn it, how that information is transferred during that first chaotic journey south with hundreds of other birds, nobody really knows for sure. It's a fascinating unanswered question.
So the Arctic tern isn't just an amazing traveler, it's also a really important part of the ecosystems at both ends of the Earth. Kind of like a feathered messenger between the poles.
Absolutely. You can think of it as a living link, and its diet is key to that role. We know how it catches food, that hovering, and then quick plunge dive into the top layer of the water.
Right, usually grabbing things in the top, half a meter or so?
Yeah, sometimes just tipping down from the surface too, or even catching insects on the wing over land near the colony. But The what it eats changes dramatically depending on where it is.
Okay, so up in the Arctic during breeding season, what's on the menu?
There, it's all about high-energy, small, schooling fish that are super abundant during the short Arctic summer. Things like sand lance, also called sand eels capelin, and young herring or cod. Perfect food for packing protein into growing chicks.
Makes sense, but then they fly 10,000 kilometers south to the Antarctic. What do they eat down there during our winter, their summer?
The diet completely shifts. Down south, they become specialists, feeding primarily on Antarctic krill.
Krill, those little shrimp-like crustaceans.
Exactly. Krill form these massive swarms in the Southern Ocean, and they're incredibly rich in fats and proteins. They are the absolute base of the Antarctic food web, and the terns switch to heavily relying on this super abundant resource during their vacation.
So, feeding on key species like capelin and sand lance in the north and krill in the south, that makes the tern a pretty good indicator of what's happening in those ecosystems, right?
A fantastic indicator. Scientists call them a bioindicator species because their breeding success, how many chicks they manage to raise each year, is directly tied to the abundance of these crucial prey species.
So if the terns start having bad years, failing to raise chicks,
It's often a big red flag that something's wrong with the underlying food web. Maybe the capelin population has crashed, or the krill aren't as abundant that year. For decades, researchers have tracked tern breeding success, and they often see clear links to fluctuations or even collapses in fish stocks. It's a sensitive measure of marine health at both poles.
which is worrying because both poles are ground zero for climate change, aren't they? This must be putting a huge squeeze on the terns.
It absolutely is. Climate change is probably the single biggest threat they face, impacting them at both ends of their migration and everywhere in between. The Arctic and Antarctic are warming much faster than the rest of the planet.
How does warming in the Arctic affect their breeding?
One major issue is something called prey mismatch. As the ocean warms, the timing of events in the marine calendar shifts. The plankton blooms earlier, and the fish that eat the plankton, like sand lance, also spawn and peak in abundance earlier in the season.
Okay. So the terns arrive back from the Antarctic ready to nest, but the main pulse of food for their chicks has already happened or is declining.
Exactly. The peak food availability is no longer perfectly timed with the peak demand from the hungry chicks. The whole system is falling out of sync. This can lead to mass starvation of chicks and widespread breeding failure, even if the adult birds seem fine.
That's devastating. And what about their wintering grounds in the Antarctic? How is climate change affecting them there?
The big issue there is loss of sea ice. Terns down south rely on floating sea ice as a place to rest between foraging trips. It's a safe platform away from land-based predators.
And also where they molt, right? Replace their feathers.
Critically, yes. Molting takes a lot of energy and makes them less mobile, so having safe sea ice platforms to rest on during this vulnerable period is really important. But Antarctic sea ice extent has been declining and becoming less predictable. Losing that vital resting and molting habitat puts extra stress on them during their supposed off-season.
So they're getting squeezed at both ends. Warmer Arctic messes up breeding. Warmer Antarctic reduces their winter refuge.
It's a tough situation. And on top of climate change, they also face direct competition from us.
How so?
Overfishing. Particularly of those small forage fish, like sand lance, capelin, and herring in the North Atlantic and other regions. These are the same fish that terns rely on to feed their chicks. When industrial fisheries take huge amounts of these fish, there's simply less food left for the terns and other seabirds.
So our fishing practices can directly lead to terns starving.
It can, and it has. There have been well-documented cases where collapses in local sandhill stocks, sometimes linked to fishing pressure, have caused near-total breeding failure in nearby tern colonies for multiple years.
That's grim. With all these threats, what can be done? Are there conservation efforts helping the Arctic tern?
Yes, thankfully. In many places, active management is needed. Sometimes it's basic stuff like controlling predators, like invasive mink or overly abundant gulls, on nesting islands to give the terns a better chance. Restoring nesting habitat is also important.
Okay. Any more creative solutions?
One really neat technique that's proving successful is using social attraction.
Social attraction, what's that? Trying to make friends with them.
Sort of. Terns are colonial nesters. They like to breed in groups, safety in numbers. So, if a historic nesting island has been abandoned, maybe due to past disturbance or predators, it can be hard to get terns to come back, even if the threat is gone. They see an empty island and think it's unsafe.
So how do you convince them it's okay?
You basically fake a party. Conservationists set up lifelike tern decoys on the island, maybe looking like they're incubating eggs or just standing around. And crucially, they play audio recordings of the calls and sounds of a busy, thriving tern colony through loudspeakers.
You trick them into thinking other terns are already there and doing well.
Exactly. This combination of visual decoys and sound playback creates the impression of a safe, successful colony. Prospecting terns flying past are much more likely to investigate and settle down to nest if they think other terns are already there. It's using their own social instincts to help them recolonize protected sites.
That's actually brilliant, using their own nature to help them out.
Well, we've covered a phenomenal amount of ground today, just like the bird itself. From that mind-boggling lifetime mileage, 3 trips to the moon and back.
Yeah, incredible. And the sheer biological brilliance behind it. The super efficient wings, the cleverly engineered bones and muscles, that amazing internal repair system.
And in navigation, using the sun, the stars, the Earth's magnetic field in 2 different ways, maybe even smell, it's just astounding.
It really makes you appreciate how finely tuned these creatures are to their environment, to the entire planet, really. We also saw how that connection makes them vulnerable, acting as sentinels for the health of oceans at both poles, but facing serious threats from climate change and human activities.
A true feathered thread linking the Arctic and Antarctic.
We really want to thank all of you for joining us on this exploration of the Arctic tern's unbelievable life story. It's a creature whose home isn't really a place, is it? It's the journey itself.
That's a great way to put it. And maybe that leaves us with something to think about.
What's that?
Well, if this tiny bird, this champion survivor, needs the health of the entire planet, from Arctic fish stocks to Antarctic sea ice, just to complete its annual cycle,
Yeah.
what does its increasing vulnerability in the face of global changes tell us about our own dependence on this interconnected world? If the tern is struggling, maybe it's a warning sign for all of us.
A powerful thought, something for all of us to consider.
Definitely.
Thanks again for listening, everyone. See you next time on Saltwater Stories.